Hey there, everybody. So I want to continue teaching today the concept of continental drift and then also introduce seafloor spreading, which is the second step into the greater theory called plate tectonics. But before I go ahead and do that, I want to make sure you guys can follow along in some of these animations and videos I've been posting. Besides putting them on the Google Classroom for you guys to access at your own time, they're also on the school's website. Well, my website through the schools. So if you went to teacher pages right here and you clicked on it, you can access any of your teacher's pages on your own. So I'm obviously Rosencrantz. So if you click on Rosencrantz, you will get to my site. Now I've shown you how to do this many times in class, but up to now you really haven't had as much of a reason to use it. So hopefully you access these. You can watch the videos on your own time. You can slow down the animations. It might work better for you. So I wanted to make sure you were aware of this. So if you go to the unit we're learning, they're always on the left here. They go in order and how I've been teaching. So right now we're up to plate tectonics. So if you go to links, that's where you would find the animations and videos I've been posting throughout the year. So these Bill Nye's and Earth's Interior YouTube, I'm going to put these on Google Classroom. By the time you watch this, it might have already been posted. So last class, I played this breakup of Pangea. I actually have two of them. I kind of like the one I showed in the last lesson better. I'm going to show it one more time. And you can play it at home. So if you click on that, you can bring it up. You can make it full screen. And you could play it along. You can split the screen, or when I'm done with my video, go back and study this on your own. So you can see Pangea when it's together. And then it was breaking apart. And if you remember what I mentioned last class, North America broke apart first. And that's why North America is much further from Africa than South America. Okay? And India for a long time was an island, and then it came crashing into the rest of Asia. Okay? And that's our current positions. Now, I have another animation up here. It's called Pangea Breakup. The reason why I didn't show it is because you need flash. So not all of you have flash, but if you do, you just make sure you allow it. Allow it always. And you can kind of zoom this up. And this one plays pretty quickly. But since there's a slide bar, you could bring it back to the beginning and stop it. I do like this one only because it tracks the time here. So you get the position of where the continents are at different times in Earth's history. So you can actually see when India collided with Asia, and that formed the Himalayas. And it collided about 20 million years ago. Okay? Which is considered very recent when you think about the age of the Earth. Okay? Which is 4.5 billion years. All right. So the one I really want to go over today, so if you go back to my website on Plate Tectonic Links, is this one titled Continental Drift Evidence Class Zone. And a lot of these also require, what's it called? Java, I guess, or the Quicken applications. So you may not be able to play them. If not, just watch along. So this is what Alfred Wegener, I never know how to properly pronounce his name. This is what he first noticed, the two giant puzzle pieces of the continents. That Africa right here, fit like a puzzle with South America. Okay, so what he did was he took the puzzle and he put it together and see how well they fit. And then he looked for some of the evidence we listed. So right here is one of the creatures that lived called Signathus. Maybe you could pronounce it better than me. This was the size of like an average dog or cat. So look, this is it here compared to a human. It looks much more large and menacing in the picture. So do you think this thing could swim across the ocean? I doubt it. But this is the only places it was found. So this part of Africa that my cursor's on is very far away from South America. So this creature, the only reasonable explanation is that the continents must have been connected and it was able to walk across. Okay. Now here is matching mountain ranges. So these are the same belts of mountains that exist in this band that's lit up in color here, in purple. Okay. And then you have a plant fossil. This is a type of fern whose seeds were extremely heavy, so we don't believe it would be possible for wind to carry it, or birds to carry it, or currents in the ocean. So we believe the only way this plant would have existed is if it was able to spread its seeds in a very close proximity. All right, so it wouldn't have been able to cross the ocean. And then you have sandstone, which is matching rock formations, okay, or minerals. And then this was the leather fossil. This one we're going to read about. It's called the Mesosaurus. It was one of the first pieces of evidence given. This is like a alligator-like reptile, but it only lived in fresh water. So unless the ocean was fresh, there's no way this thing would have crossed. All right? Because the ocean's salt water. You didn't know that. Okay. Next up. All right. So until the 60s, this theory of continental drift was not fully accepted. So Alfred Wegener came up with his theories in 1918 or 1920. I don't remember it off the top of my head. But it really wasn't until World War II, World War I and World War II, with submarine technology, that we had sonar. So submarines had to know, how far was the seafloor. So before that, we really didn't know how deep the oceans were. And common sense would tell you that the oceans should be deepest in the middle, right? Because as we walk into the ocean, it gets deeper, 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 deeper. So we would assume, based on common sense, that the ocean should be deepest in the middle. But actually, that's not true. The middle of the oceans were actually quite shallow, and the coastlines had the deepest parts of the ocean, called the trenches. And that really threw everybody off. That was a tremendous discovery, that the middle of the oceans were actually quite shallow, and the edges of the oceans near the coastlines were actually the deepest. Totally opposite of what common sense would tell you. So here is a profile drawn. So this is South America here, and I'm going over this red line, if you could follow my cursor, to Africa. And if we map the seafloor, the depth, you would actually get the middle of the ocean to be quite high, which means the water is shallow. So this is a ridge. So basically, the ocean kind of goes down and then up in the middle and then down again. So see, down, up in the middle, and down again, and then back up in the coastline. So the middle of the ocean was shallow, and we call these the mid-ocean ridges. So the middle of every ocean actually has a mountain range. And we name the mountain range for whatever ocean it's in. So if it's in the Atlantic, here it is, Mid-Atlantic Ridge. Okay, instead of being called ridge, sometimes it's called a rise. So since the Indian Ocean is so big, there might be like a southeast Pacific rise or a west Pacific rise or ridge. They're actually all connected. They're very shallow. And what is also very interesting is not only are they shallow, they're all volcanoes. And volcanoes are spitting out new rock. So this was a crazy discovery. The middle of every ocean was shallow. Not only that, they were all volcanic. People thought the ocean was this featureless, flat abyss, kind of unchanging forever. But in reality, it's actually changing a lot. It's got mountains, it's got valleys, and in the middle of every ocean is a volcanic mountain called the mid-ocean ridges. And I'll show you that in the next slide here. Okay. So what you're seeing here, this gray, let me enlarge that, is the continents. All right. And these colors are on the seafloor. And if you remember, I said North America separated from Africa first. What I mean by first is before South America separated from Africa. So if that's true, we should be able to figure out the time difference. So if you look here, see the dark blue by North America and the dark blue here by North Africa? Those rocks on the seafloor are 180 million years old. But then in South America, see, it's green, and in South Africa, it's a green. So these rocks are about 100 to 120. See right here? You see those colors? Which 100 to 120 million years old. That means that North America broke apart from Africa about 80 million years before South America broke apart from Africa, which helps explain why North America is so much further away from Africa than South America. And then if you look here, see this really bright red? Let's pick up on two things this map shows us. For one, look at it. It's the same exact shape as the African coastline. See that? It's pretty cool. This is the Mid-Atlantic Ridge. These are your volcanic mountains in the middle of the Atlantic. And the theory is that they're continuously erupting and they are spreading the continents apart. So the continents were once touching here, and over time, with the volcanoes erupting, it's pushing the seafloor sideways, making the oceans spread. And we call this theory seafloor spreading. And that's that the seafloor is spreading from the ridge, all right, and getting created there. And see that it's red? So if you look here, you look at red, 0 to 9.6 million years. So these are your youngest rocks in the world. All right. So this is the beginning of the theory called seafloor spreading, and it gave a lot more evidence to the continental drift theory. Okay. And it helped to make this greater theory that I mentioned quite a few times called plate tectonics, which we're still going to learn more about. All right. I'll post another video later going over even more evidence of seafloor spreading. Okay. Watch this. I hope you make use of the tools I showed you on my website. And as always, email me with questions, and we're going to be doing those Zoom or Google Meet meetings. I haven't decided yet, but I did send out the calendar. So I can always bring these up at the meetings and we could discuss. All right. Have a great day. I know how to turn this thing off. Oh, I'm still here.